Hello guys, and today I would like to talk about the history of artificial intelligence, or you can tell the birth from where the artificial intelligence was started, and few projects were made which were advanced at that time and even advanced today, because from that projects only we are learning today. And if you don't know those projects, so maybe there are chances that you will lack the information about where we have to go and through in what process we should process the information so that we can get to the end points. So in these slides I will talk about the early 1970s or mid 1980s when these all projects were started. So these projects name, as I have written already, the Dendral, MYCIN and Prospectors. These were the only projects which gave birth to the artificial intelligence and gave a new form of knowledge. So let's see what happened and what are the things that they did but not completely did, and what we can improve in that. So we will understand in these slides. Nowadays we know artificial intelligence as an intelligence system, but back in the 1970s they were all known as the expert system, because now, as you know, that language improves itself, but previously it was not so improved. Then it was known as the expert system because they were expert in doing various types of works, and now we are making machines to be intelligent. So that's why today we know it as an intelligence system, but previously we are trying to make the system expert in doing things, so that they were known as the expert systems. The first project which was very famous was the Dendral. It was made by the Stanford University. The project was even supported by the NASA because the unnamed spacecraft was to be launched to Mars, and the program was required to determine the molecular structure of Martian soils. So with the help of artificial intelligence, or back in days what is known as the expert system, so with the help of expert system we can determine the molecular structure of the soils present in the Mars. So this project was even supported by the NASA also, which gave a major paradigm shift for the from the general purpose to knowledge sparse, from the weak method to domain specific knowledge, and the intensive techniques were used. So this program, the Dendral system, was the best at that time, and it's even best today, because mostly it is this method is only used to send the spacecraft to the Mars and all. The specific aim of this project was to make an expert system which could be as experienced as the human chemist, because we can't send the human chemists to the Mars, or we can't send the we can send, but we should not, because there are the chances that the human may die, or other systems may crash, or the lack of knowledge can create a loss of amount that was spent on the project. So that's why the expert system were best. It gave a new methodology of expert system to the knowledge engineering, which encompasses techniques of capturing, analyzing and expressing in rules of experts know-how. So this was the best projects at that time and even today, because this project only gave birth to the expert system. So from here only the expert system was started. Now here comes the next big change in the artificial intelligence, the project MYCIN, which was developed and was better than the previous project firstly, and could perform at a level equivalent to human experts in the field, and considerably they were better than the junior doctors available. So this machines was considered better at that time, and it was a better expert system at that time. It had various statements written, and it had around 450 if-else statements. With the help of these statements only, these machines can perform various other tasks at very speedily. At that time it was speedily because today we have the various strong machine. We have the quantum computers as well coming to the market. We can't say today, but at that time they were very speedy and can perform various tasks very easily at that time. This project even had a domain independent version, MYCIN, which was known at that time. It was developed by the Stanford University, and it was helpful to determine if the blood is infectious or not non-infectious. So this machine could tell you with the blood samples that if your blood is infectious or not. So the MYCIN is known as the empty MYCIN. It even have the variety of diagnosis systems into it. MYCIN also introduced a new features. Rules incorporated in MYCIN reflects the uncertainty associated with knowledge, in this case with medical diagnosis. It tested rules conditions against available data or data requested from the physicians. When appropriate, MYCIN inferred the truth of a conditional through a calculus of uncertainty called certainty factors. Reasoning in the face of uncertainty was the most important part of the system. Another probabilistic system that generated enormous publicity was the Prospector, an expert system for mineral exploration developed by the Stanford Research University. The project ran from 1974 to 1983, and 9 experts contributed their knowledge and expertise. To represent the knowledge, Prospector used a combined structure that incorporates rules of a semantic network. Prospector had over 1,000 rules, maybe more than 1,000 rules to represent extensive domain knowledge. It also had a sophisticated support package, including a knowledge acquisition system. The Prospector operated as follows. The user, an expert geologist, is asked to input a characteristic of a suspected deposit, the geological settings, structures, kinds of rocks and minerals. Then the program compares these characteristics with models of ore deposits and, if necessary, queries the user to obtain additional information. Finally, after obtaining all this information and looking at the pictures which was given to the system, finally after that the prospector makes an assessment of the suspected mineral deposit and presents its conclusion. It can also explain the steps it uses to reach the conclusion. So that's why even the Prospector got it enormous publicity, and it was famous amongst the people because it can tell what are the deposits available, and it was better than the human to tell that yes, this is the name of the deposit, and without any further information required. Now the reason was all these systems were based at their usage, and all the systems were experts in their usage. Still the project failed. Every project failed. What was the reason for the failure? The expert systems were at that time very restricted to a very narrow domain of expertise. For example, if I am talking about the MYCIN, which was developed for the diagnosis of infectious blood disease, lacks any real human psychology. If a patient has more than one disease, we cannot rely on the MYCIN. In fact, the therapy prescribed for the blood disease might even be harmful because of the other diseases. So in that case, because the MYCIN was specific to the blood disease only, and it can only tell the infections which the blood have. So suppose if a patient is having fever as well as infectious blood, so the MYCIN can only give the medicine to the infectious blood. The fever may not go, maybe due to some other reasons. So due to this reason, the MYCIN project was not considered good. It was, I will not say that it was a bad project, because it can even say that the blood is infectious, which was very good at that time, but it was not as helpful as it was to be considered. And because of the narrow domain, expert systems are not as robust and flexible as the user might want. Furthermore, the expert system can have difficulty recognizing domain boundaries when given a task different from the typical problems. An expert system might attempt to solve it and fail in rather unpredictable way. Expert system had limited explanation capabilities. They can show the sequence of rules they apply to reach the solution, but cannot relate accumulated heuristic knowledge to any deeper understanding of the problematic domain. Expert systems are also difficult to verify and validate. No general techniques has yet been developed for analyzing their completeness and consistency. And one of the main reasons of the failure of expert system was especially from the first generation expert system, they have very little or no ability to learn from their experience. Expert systems are built individually and cannot be developed fast. It might take 5 to 10% to build one expert system to solve a moderately difficult problem. Complex systems such as we have discussed previously, Dendral, MYCIN, and Prospector can take over 30% means and years. 30 years, suppose they are taking 30 years to build this large effort. However, would be difficult to justify if improvements of the expert system performance depends on further attention to the developers. But nowadays we have more expert system, because now I think iPhone watch has launched which can tell the blood oxygen level, so it is better than the MYCIN which was previously developed. So I maybe see what are the complications of the Apple watch. I can't tell now because I don't know, I have not used it, but maybe there could be some complications, or it might be better than the MYCIN. So let's hope for the best, and thank you for listening to my lecture. And if you like it, please like, subscribe, and share. Maybe your help can help me. Thank you.